Hello, Honors Math 2. If we were together at school today, I would have this huge on the whiteboard, and I would welcome you to Honors Math 3. Today we start the first module, Module 1 of Honors Math 3, looking at some composition of functions and inverses. Alrighty, we're in our warm-up today. If you're able to print these notes, it just makes it a little easier for you to have something to look at. If not, you can kind of follow along. Maybe some scratch paper and a calculator would be helpful. Quick review of function notation. This is very algebraic as we get started. Function notation. Remember, for function f of x equal to 2x plus 1, this represents my inputs of x, and this expression over here will generate my outputs. Okay, we're going to add some things to that as we take some notes. So that means if I'm evaluating g of 2, that means I'm going to look at my function g and I'm going to input 2. Wherever there's an x, I'm going to input 2. What is that? 2 squared minus 3 times 2. You remember this. We're just getting rolling. Pause and evaluate that, please. Okay, when I plugged in g2 into g of x, I get an output of 1. That means that the value of g of 2 is 1. Just a little bit more on notation. Remember that the inputs into a function are sometimes called the domain. So those x values represent the elements of the domain. And then the expression on the right generates elements of the range, the outputs. Remember, sometimes we have to be careful of the domain, the inputs. Into this function, there's only certain things that I can plug in because I can only take the square root of positive numbers. That means that this expression, x plus 6, has to be greater than or equal to 0 to be positive. That implies that x values have to be greater than or equal to negative 6. So notice in this function h of x, the domain is all x values greater than or equal to 6. You can write it this way or this way for the domain. Let's take a second and evaluate f of negative 8. Now I go into that function f of x, 2 times negative 8 plus 1. Can you pause and evaluate h of 10? Input 10, and I get 10 plus 6. Pause and evaluate those two functions. Evaluate, and I get f of negative 8 is negative 15. Evaluate, and I get h of 10 is equal to 4. Alrighty, let's move on if we could. We define this important composition of functions, or composite functions of functions. Given two functions f and g, the composite function, denoted by, here's the notation, that little circle, and we read that as f composed of g. F composed with the function g. And that notation, f composed of g of x, is equivalent to f of g of x, where we're plugging the whole function, g of x, into that function f of x. We're going to be careful of the domain of a composition of functions. The domain of f composed of g is the set of all numbers x in the domain of g, such that g of x is in the domain of f. Notice I'm going to plug x into g of x, and then plug that output g of x into f of x. So, just to save us a little time in writing, so x needs to be a valid input into g of x, needs to be in the domain of g, and so I input x into g of x, I get that output, and g of x, which is that output, needs to be a valid input into f. That function needs to be in the domain of f. Let's look at an example. First of all, we're going to find f composed of g of x is that first notation. If that's confusing, we'll just write that as f of g of x. Start on the inside, and I'm going to plug that whole function g of x, what was g of x? 2x plus 3, into f of x. If I input that whole function into f of x, first of all, we're going to state the domain of our composition also. Look at this function by itself. The domain of that inner function is all real numbers. That thing is just a linear function. I can plug anything into it, and the domain is from negative infinity to infinity. But now I'm going to take 2x plus 3, this whole thing, and input it into f of x. So I'm going to put it wherever there's an x. That becomes 2x plus 3 squared plus 3 times 2x plus 3 minus 1. Plugging that whole expression 2x plus 3 into f of x. I'm going to pause so you can start to simplify, but remember this thing squared is 2x plus 3 times another 2x plus 3. Distribute, and then subtract 1. I'm going to pause. Okay, you can check your work. I FOIL. I combine like terms, and that means that that original composition, f composed of g of x, is equal to this expression. I have to make sure that I follow the domain of the inner function, which is all real numbers from negative infinity to infinity. Notice the domain of this function is also negative infinity to infinity. So the domain of the whole composed function is all x values from negative infinity to infinity. Let's go the other way. Let's find g composed of f of x. Notice that means it's easier to write it, I think, as g composed of f of x. That means I'm going to take that whole function f of x and plug it into g of x. What was f of x? F of x was this one, x squared plus 3x minus 1. Heavy duty on the algebra here, isn't it? As we start this module, first module of Honors Math 3. So I'm going to plug this into g of x. Wherever I see an x, I'm going to plug in that whole expression. So that's going to be 2 times the quantity x squared plus 3x minus 1. Oops, plus 3 at the end. Plus 3. Okay, distribute, combine some like terms, and let's see what you get for that composition. When I distribute and combine like terms, I get this expression. So g composed with f of x is equal to this new quadratic. The domain here is no problem, negative infinity to infinity. The domain here is negative infinity to infinity. I checked twice. That means that the domain of the composed function is negative infinity to infinity. I have to make sure I have valid inputs into this function that produce valid outputs from that function. Okay, but we'll spend some more time on that domain and range in just in just a second. Okay, here's the two new functions, f of x and g of x, and here's some good computation practice just with regular numbers that are numerical inputs rather than those whole functions, f of x or g of x. Remember that confusing notation of a composition of functions that's equivalent to f composed of g of 1. Start on the inside, and I want to figure out what is g of 1. I'm going to come up here to g of x, and what is g of 1? G of 1 is equal to 4 times 1, which is 4. So g of 1 is 4. Work from the inside out. Now I want f of 4. I'm going to come over here to f. When I plug in 4, that's going to be 2 times 4 squared minus 3, whatever that is, 16 times 2, which is 32 minus 3, and I get 29. Let's try that the other way. That composition of function means g composed of f of 1. Start at the inside. What is f of 1? Let me come over here. F of 1 is equal to 2 times 1 squared minus 3. So f of 1, I'm going to plug that output from this into g of x. What is that? 2 minus 3, which is negative 1. And what is g of negative 1? Plug in negative 1. That's 4 times negative 1, which is negative 4. Use what we did and see if you can evaluate those two composition of functions. I rewrite them first. Okay, thanks for checking how you did. What was f of I rewrite first. f of negative 2. Check your work was 5. F of 5, I get 47. I like to rewrite first. What is g of negative 1? I got negative 4. Plug that output into g again, and I get negative 16. Let's look at a composition of functions. Find f composed of g of x, which is the same as f of g of x. We're going to find the domain of a more complicated composition of functions. Okay, so let's plug in g of x into f of x. That is f of, what is g of x? G of x is this function, 4 over x minus 1. We'll call that a rational function next year. It's a ratio. Alrighty. I like to notice the domain of that inner function right away, because I can't go any further with a undefined value from that inner function. Alrighty, so notice for that inner function, I can't have a 0 in the denominator, otherwise my fraction is undefined. So x minus 1 cannot equal 0. That means x cannot equal 1. So notice the domain here is x cannot equal 1, or sometimes you guys wrote that as negative infinity up to 1, united with 1 to infinity. Okay, so that's for the inner function. Now I'm going to plug that whole function into f of x. Wherever there's an x, I'm going to plug in that whole function. This gets complicated. 1 over, plug in that whole function for x, which is 4 over x minus 1 plus 2. Okay, I'm going to clean up this terrible compound fraction. I'm going to put that over 1. I'm going to get a common denominator. I'm going to pause there and get a common denominator. Okay, this is good prep for next year. So to get a common denominator, which is x minus 1, I'm multiplying this fraction by x minus 1 over x minus 1. Now I have a common denominator of x minus 1. Distribute, I get 2x minus 2. And I'm going to add those two fractions on the bottom, and this becomes 1 over, add your numerators, 2x minus 2 over x minus 1. How do I divide 1 by that fraction? I multiply by the reciprocal of the denominator, and that composition of functions becomes x minus 1 over 2x minus 2. And if you're working with me, you noticed I just made a mistake. When I combine these like terms, that's a positive 2x, 4 minus 2, which is positive 2, positive 2, positive 2. Notice this denominator cannot equal 0. So that means that 2x plus 2 cannot equal 0 in my result. 2x cannot equal negative 2, and x cannot equal negative 1. Okay, so this is a tricky one in the domain. Up here, x could not equal 1, otherwise this function is undefined. At the end, my composition of functions, that denominator cannot equal 0, so x cannot equal negative 1. And I get a composed function of x minus 1 over 2x plus 2 for the domain as long as x is not equal to 1 or negative 1. I like writing my domain this way. Some of you will like writing the domain as negative infinity all the way up to negative 1, united with negative 1 all the way up to 1, united with 1 to infinity, because you're more familiar with that from Honors Math 1. All right, that's a complicated one. Don't worry too much. But it is good practice to kind of see that our domain does have restrictions in it at times. Okay, let's try to read a composition of functions. And you have a nice worksheet for homework, so you'll practice all of this again and check your solutions. Let's try to evaluate composition of functions given a table of values. So I input these x values into f of x, and I get these outputs. But when I input those x values into g of x, here's my outputs for g of x. If it helps you, f composed of g of 1 is f of g of 1. That's f of, I don't know, what is g of 1? Let me use my table. When x is equal to 1, g of x is equal to 0. If I put input 0 into f, there it is. What's my output from f of x? Negative 1. And that's the value of that composition of functions. If it helps you to rewrite, this is g composed of f of negative 1. Give it a try. This is the same as g composed of g of negative 2. There's a cool case in your homework too where we use a graph to evaluate a composition of functions, so careful on that one and check some solutions. Okay, let me pause so you can try them. Okay, start from the inside and work your way out. F of negative 1, which is negative 3, and then g of negative 3, which is 8. G of negative 2, look on the inside, g of negative 2, which is 3. And then g of 3, come back over here to 8. All right, and again, you have day 1 homework, which is a nice little worksheet, and check those solutions. Okay, thanks for tuning in, and have a great afternoon. Bye-bye.